So hello everyone, welcome back to this class. Now, due to this free deflection, what you can write CL at the tail, you can write CL alpha of the tail into alpha of the tail and plus CL delta E into delta E. Okay, you can write free. Okay, since CL naught is also 0 because tail is made of symmetrical airfoil. Okay, so what you can do, you can put this expression ch alpha tail into alpha of the tail and ch delta E into, okay, this you can put, right? Now you can take cl alpha into alpha of the tail common, then you can write 1 minus cl delta E into cl alpha of the tail and ch alpha of the tail divided by ch delta E. This you can write. Okay, this factor you can write f. Okay, and since this is a cl of the tail, if you differentiate you will get cl alpha of the tail. You can put dash here because this is, we are dealing with free, elevator free, right? So you should differentiate between cl without free and with free. Okay, alpha of the tail into f. Okay, all right. So now when you write cm naught, already we derived, this is what cm naught of the wing plus cm naught of the fuselage plus eta vh cl alpha of the tail. Okay, and what will be this term? iw epsilon naught minus it. So in the case of free elevator, okay, you can call it, it's a stick free condition. Okay, you can see elevator is free to rotate, so we'll put dash here. Okay, all right, you can put dash dash dash. Okay, and what you, how will you write cm alpha? This is cl alpha. Okay, xcg by c minus xcc by c plus cm alpha of the fuselage minus eta vh cl alpha of the tail, you put dash 1 minus dou epsilon by dou alpha. Okay, and you will put right dash here also, and this is dash also. Okay, so when you write neutral point, so how will you write the neutral point? Okay, you put this cm alpha equal to 0 and you may write this dash because cg position will be neutral point, right? xac by c and eta vh cl alpha of the wing, right? So this is wing, right? No need to put dash. Okay, cl alpha of the tail, cl alpha of the wing. Okay, and 1 minus dou epsilon by dou alpha. Okay, so and this you can write f into cl alpha of the tail. Already I explained to you what do you mean by f. Okay, so what will be the xnp? Xnp dash, that will be the xac by c plus eta vh f cl alpha of the tail divided by cl alpha of the wing into 1 minus dou epsilon by dou alpha. And what is stick fixed? Already as I explained to you, xac wing c plus eta vs cl alpha of the tail 1 minus dou epsilon by dou alpha. So if you subtract these two equation, x n p by c minus x n p by c, this is free case, this is fixed case, this x by c will cancel and you left with 1 minus f eta vh cl alpha of the tail cl alpha of the wing 1 minus dou epsilon by dou alpha. Okay. So that f will decide whether on a this line, let's say this is what, this is let's say xnp, this is tail part, this is nose part, this is cg. Okay, so f will decide whether what will be the location of stick free neutral point and stick fixed neutral point. Let's say if f is less than 0, so that means x in p will be greater than what is going to f. If f less than 0, this will become, this part will become positive. So x n p dash matlab stick free case will be greater than stick fixed case. So you can place like this in the point. Okay, so here you can define stick fixed neutral point. How you have defined? Like this, right? That is for fixed case, right? You are not allowed the elevator to be free, and this is free case. Okay, so mathematically that is a difference between stick free case and stick fixed case, and physically I try to explain you when you do this the how the elevator will float up. If you have any doubt regarding the hinge moment, neutral point, flight measurement of a neutral point as a designer, where you place the hinge line and how will you zero out the hinge moment to reduce the pilot workload, you can ask me in the comment section. I will try to explain you, and you might witness that ki when you are in aircraft like 2-seater or 6-seater, generally you see the pilot uses the trim wheel in order to zero out the hinge moment. So basically when you do this, so you are deflecting the tab actually, like I have explained to you, when the elevator is going down and you are putting the wheel like this, and at that time the elevator tab is going to the up direction, and when you start feeling that I do not have any load, that means hinge moment is 0. So in detail, if you want to ask me, you can ask me in the comment section. I will try to explain you. Thank you so much.